Okay, recording progress, and welcome you all. My name is Dario, and I'm one of the maintainers of the Kubernetes Multi-tenancy on the Meetup group. So what we're doing here, we are trying to evangelize in regards of multi-tenancy on Kubernetes. So when you're using a shared cluster to provide access to a set of developers, or maybe sharing multiple clusters with different tools. And today we have, for the second time, the people from Nirmata, the company behind Kyverno, and we already had Dolis, and it was great. And we had a lot of interest asking to get further details about the projects itself. So we got also Anusha. So maybe you could try to unmute yourself so you can provide a brief overview of what we're doing at Nirmata and about the project itself. So it would be great just to get in touch with the attendees. So Doris, Anusha.
Cool. So yeah, today we are going to talk about how do you secure your cluster using self-service model with IAC and Kyverno. So we have a couple of slides, and Anusha, you can start sharing a slide. But before we jump into the topic, let me quickly introduce myself. My name is Dolis, and I'm a senior customer success in Nirmata, and I'm based out of Halifax, Canada.
Yeah, hi everyone. So I'm Anusha. I'm a technical product manager at Nirmata. So I manage the enterprise Kyverno offerings, and we also have a SaaS solution called the Nirmata Policy Manager. I am also involved in the policy working group, and prior to this, I was part of Cluster API and providers. I'm really excited to be here, so thank you for having us. I think we can get started.
Yeah, absolutely. Keep in mind that, Anusha, you should be able to share your screen. Just a brief overview also in regards of the rules. So please, people, don't unmute yourself. You can use the chat to ask any kind of question. We are going to have also a Q&A session at the end of the presentation. Should be 5 minutes. The presentation should last between 30 and 45 minutes. Dolis, Anusha, confirm that. Otherwise, I'm sorry for the wrong information. And I think that we can proceed.
Thank you.
Thanks.
So yeah, you already know us. So moving ahead. So this is what we are briefly going to cover in today's talk. We'll start with the Kyverno what and why. We wouldn't be spending too much time on this because, like Dario mentioned, Dolis and Jim have already spoken about this. So we'll just talk a little bit about it so that we can level set the field for everybody. And then we'll talk about the latest release of Kyverno, which is 1.9. There are some cool features that have come out, so we'll talk about them. And we'll also look at what's next for Kyverno. So 1.10 is also on the card, so we'll talk about what are some of the features to look out for in 1.10. And then Dolis will talk about what is cluster as a service, what are the different use cases, and we also have a live demo plan for you all. In the end, we have Q&A, but feel free to drop your questions anytime and we'll answer them throughout the call. All right, moving ahead. So what is Kyverno? So Kyverno is a Kubernetes native policy engine. So when I say Kubernetes native, it means it follows all the Kubernetes constructs of CRDs, controllers, labels, selectors, and so on. So it is just like using any other Kubernetes resource, or if you're familiar with a custom resource, so it is just as using that. It is created and maintained by Nirmata, and it's also a CNCF incubating project. And we have seen tremendous growth and adoption over the past couple of years. We recently hit 1 billion image pulls, which we're super proud of. And then we have over 3.7K stars on GitHub. We have 1,500 plus Slack members. We are always active on Slack. So if you're on the Kubernetes Slack, do join the #Kyverno channel. And we have a huge library of 250 plus policies. So if you're just getting started, or if you want to find policies for a certain use case, so there's a very good chance that you will find a sample policy in our library. And these are all the companies that are adopting Kyverno, and this list is sourced from our adopters list. So yeah. So why Kyverno? So Kyverno has wide application in a vast area of your software lifecycle, starting from the CI/CD pipelines. We have a Kyverno CLI that you can use in your GitHub Actions as a quick dry run or for a static analysis. Suppose say you have resource manifest, and then you have a set of policies you want those resources to be compliant with. you can use the Kyverno CLI to do a dry run or a check of whether those resources are complying with your policies or not. So this acts as a fail fast method. So in your CI/CD pipeline itself, you'll get to know that whether this particular resource is going to ultimately get blocked during the time of admission, or it's going to be passed. So if it's going to be blocked, you can take measures to fix it at the CI/CD stage itself. So not just CI/CD, we also have Kyverno acts as an admission controller. So at the time of API request admission, you can make decisions on whether to allow the resource or deny the resource. And not just that, for resources that are already in your cluster, you can perform background scans, and Kyverno will give you a report of how many violating resources are already there in your cluster so that you can take necessary actions. And these are some of the top use cases that we have encountered. We have just categorized them into security, ops, and costs. I'm not going to talk about all of them, but maybe I'll highlight a few. So definitely the pod security. So Kubernetes has guidelines on pod security standards. There's a baseline profile and a restricted profile, so you can write Kyverno policies for them. You can have granular RBAC. You can control your cluster rules or roles to allow only certain verbs or resources. And then, of course, there's image signing and verification. Kyverno currently supports cosign. So if you're using cosign to sign your container images, you can verify signatures at the time of admission as well. And in terms of operations, we have namespace as a service, cluster as a service. So this is going to be the highlight of our talk today. Dolis is going to be talking in depth about this. So I'm going to leave this for her. And then in terms of costs, you can set pod requests and limits. So whenever, suppose say you create a new namespace, you'd obviously want to attach labels to it, create namespace quotas, create network policies, and you'd want to do a lot of housekeeping activities whenever you create a new namespace. So you can do all of that, and this also helps in monitoring costs, in making sure certain namespaces do not go beyond certain costs. So yeah, moving on. Okay, so this is basically Kyverno architecture. The top line over here, the gray part, is has nothing to do with Kyverno really. So this is the life cycle of an API request. So whenever a client creates a request, it goes to the HTTP handler, it goes through authentication and authorization. And at that point, if you have registered any webhooks with your API server, first the mutation admission webhook will be called. And if you do any mutating actions, the schema validation happens so that you are mutating all the right things and they adhere to the schema. And after that, we have the validating admission control. And here you can decide whether to admit your resource or not. And if you admit, ultimately, it's going to be persisted in etcd. So this is the API request lifecycle, starting from the client creating the request to the request ultimately getting persisted by etcd, or there's a possibility that it might get rejected in one of these stages. So where does Kyverno fit into all this? So Kyverno is basically an admission review, where it acts both as a mutating admission control and also as a validating admission control. So if you see it, at the heart of it is the Kyverno engine itself. So this engine is responsible for processing all the rules that we write in terms of policies. And then it has a bunch of controllers. Like I mentioned earlier, Kyverno follows all the Kubernetes constructs. So you have a bunch of controllers. So all of these yellow things here are CRDs. So each policy, you can write it as a CRD. And there are different set of reports that you get. You get admission reports, background scan reports, policy reports, and so on. So all of this together, along with the core engine itself, they form the Kyverno ecosystem. And yeah, these are the three main highlights for this. Kyverno acts as an admission controller. It can act as a background scanner. And of course, we have the Kyverno CLI for static analysis. Both the CLI and the background scanner make use of the same Kyverno engine for rule processing, so that it's the same engine that powers all of the use cases. So this is the basic architecture for Kyverno. So are there any questions? No. Okay.
Not so far. Yeah, we can continue. Thanks.
Okay. Thank you. Yeah, so this is the anatomy of a Kyverno policy. So if you are familiar with Kyverno, you should probably now figure out what is this. So for every policy or a given policy can have multiple rules. That is the one is to start relationship here. You can have multiple rules in a given Kyverno policy, and each rule you can specify either match or exclude. It means you can match on certain resource kinds, names, labels, namespaces, and a whole bunch of things. Similarly, you can also exclude the rule for the resource kind names and namespaces. So once you specify on what resources you want to match or exclude, you then move on to the rule types. There are 4 main rule types. One is mutate, verify images, validate, and then generate. So these are the 4 main rule types with which you can write. We already have 250 plus policies. I'm sure more are coming. So these four rule types are pretty powerful. I'll probably show you an example of a validate rule type. Yeah. So here, this is a cluster policy. So just like we have cluster role and role, a cluster policy is applicable throughout the cluster. And if it's just a policy, then it's applicable to only certain namespaces. And then we have a validation failure action. Here it is set to enforce. It means if any of the rules are not adhered to, that is, if your incoming request fails any of the rules, then your request is going to be blocked. You can also set it to an audit mode, wherein it will only create a report, a kind of a warning that, hey, your resource has failed some rule, but I'm still going to allow the admission. And then we have rules. Just like we saw in the anatomy here, we can have multiple rules. So the rules is an array. So here you can say match on what resource kinds you want. Here we don't have any exclude block, but if there was any, it would be at the level of match itself. So you can match on different kinds of resources. You can also match on the resource names. And then this is the validate policy. So here in this rule, we specify what is the thing that you want to validate. This is saying in your spec template, there should be labels, and there should be a key called app, and it should have some value. So Kyverno supports extensive regex, but this is something simple, saying there should be at least some value for the key called app. Similarly, this is a mutate policy. So here, if we see instead of the validate keyword, we have mutate, and everything else is same. And mutate can have different strategies, or it can have its own spec that you'll have to write. So if you have to look at the overall anatomy of this, you just have policy or a cluster policy, and then you have some rules, and each rule can be of validate, mutate, verify images, or generate. So, okay. Now that we know about the basics of Kyverno, let's directly jump to the latest 1.9 features. So there are some of very cool features that have come out in 1.9, and one of them is policy exceptions. So when I spoke earlier about we can have match and exclude blocks, in the exclude block, you can say on what resource you want to exclude or what namespace you want to exclude. But the problem here is if I'm a SecOps person or I belong to the security team and I see my organization has to be compliant with certain set of policies. Let's take an example of we have a policy that says run as root is always set to false. We don't want to give root access to any of our containers. So, but what if one of my developers want to debug something or they want to troubleshoot something and they want to exclude their particular namespace or their particular deployment from this particular policy so that they can do their debugging. Prior to 1.9, the way to achieve this was to, in the exclude block, include their namespace or the deployment that they want. But this is not very scalable, right? Now I have to manually edit the policy to exclude my certain namespace and also make sure that, we remove the exclude block once my debugging is done. So me as a security person, I would not want my developers to be editing policies, right? We do not want them to keep that access to edit the policy. That is where I think what this feature provides is policy exception is a brand new CRD. With the CRD, you actually decouple the policy itself from the exception. I think let's look at the example. Okay, so this is what happens in terms of policy exception. So say we have a validate policy, it is in an enforce mode, and the user or a client sends a violating resource. So generally we would expect that this particular resource is blocked because my policy is in enforce mode. But now what if a matching policy exception exists? I'll talk about what is a matching policy exception, but let's say it exists. So if it exists, we're actually going to allow the resource. But if we don't find any matching policy exception, then we are going to block the resource. So yeah, here is an example. So this is my cluster policy. This says disallow host namespaces, and this is an enforce option. Now, in the validate rule, I have sharing the host namespaces is disallowed. So now what if I have an incoming resource, an incoming pod that actually has one of these values as set to true? In an ideal scenario, this resource has to be blocked. Now again, somebody wants to debug or troubleshoot something and they want access or they want to share the host namespace. So in this case, what we can do is we can write a policy exception. Like I said, it's a completely brand new CRD and it is decoupled from this existing policy. So all it expects is that when you specify certain exceptions, you have to say what policy you want the exception for. So this policy has to exist. And within the policy, you can say apply to only rule A, B, or C, or only to rule A. So here we are saying in this policy, we have to match with rule host namespaces and autogen host namespaces. And then similar to match that we saw earlier, we can match on resource kinds. Here we say for all pods and deployments in the Delta namespace, and for all resource names starting with the important tool, this policy is not applicable. That is, this policy can be bypassed. So this is how you create exceptions for policies that are already there. Now, if you're a security person, you can be assured that nobody is going to edit your policies themselves. You don't even have to give access to anybody else other than the security team to edit policies. All you have to manage is who is given the access right to create policy exception. So here you can make use of Kubernetes RBAC to create roles and only make sure certain users are able to create policy exception, because we don't want everybody to be creating policy exception. That just beats the purpose of having policies, right? So yeah, so this clearly decouples existing policies to exceptions, and it is slightly easier to maintain as well. Going back to the set of features. Yeah, next cool feature is cleanup policies. So one of the most loved features of Kyverno is the generate rule type, because suppose say you create a new namespace, you can actually create resources on the fly. Whenever you create a new namespace, you may want to create network policies or resource quotas, and it is possible to create these resources as and when a new namespace is created. That is where you would use the generate rule type. Now we have users asking about, we have generate, that's great, but what about, cleanup? Can we have something for cleanup? That is where we came up with cleanup policies. Again, this is a brand new CRD. So what you can do is you can set up cron schedules that say delete all bare pods at 5 p.m. every day. So what it would do is actually look at pods that don't have any owner references, and then would completely delete it at 5 p.m. every day. So with this, you can be rest assured that there are no bare pods in your system, or you can write cleanup policies for almost any resource. And one of the cool features that is combining 1 and 2, that is combining policy exception and cleanup policies, is actually time-based policy exceptions. So if you think about it, you don't really need policy exceptions to persist for long, because they are there only for those one-off scenarios when you want to debug or troubleshoot. You wouldn't want a policy exception to stay longer, because you would want all the bad resources to be blocked, but only for that certain duration of time when your developer is debugging, you want to make that exception. So policy exceptions combined with cleanup policies, you can set up a policy to be something like clean up my policy exception after, say, 5 hours or after 2 days, so that you can be rest assured that the policy exception is not going to be long-lived and everything is going back to what it was after, say, the specified time in your cleanup policy. So there's a very nice blog written by Chips, which I have linked here. So it's called Temporary Policy Exceptions, and there's a very good example of how you can achieve this. So please go through that. Next, we have distributed tracing. So prior to 1.9, we added support for open telemetry, but with 1.9 and with distributed tracing, you can actually, keep track of how long each rule processing is taking. And if you have to make external calls, such as registry lookup in terms for cases like image signature verification, you can track how long that external call took. And this is very helpful, not just in monitoring, but also when you're troubleshooting something to figure out, why certain rules are taking longer to process, or if there's some other performance deal. So distributed tracing is another great feature in that area. And then we have extended support for sub-resources. So this was already there. We have made some enhancements. And then we have config map caching. So even prior to 1.9, Kyverno could look up values from config map if you want to base certain decision on the data stored in config map. We had a few users report that in cases of large clusters, this was taking a performance hit to make that lookup to the config map. That is where we introduced caching. So all you have to do is add I think a label or an annotation to your config map, and Kyverno will automatically cache it for you, so that your lookup is faster and it gives a performance boost. So these are some of the new features that have come out in 1.9. There's a complete blog with all the details of each of these features. So feel free to go through them. Are there any questions, or can I move on?
No questions so far.
Okay, great. Okay, so 1.9, everything is great. So many cool new features came in, but we are just getting started. So there are a ton of things coming up in 1.10. And I think earlier this month, there was a webinar from the maintainers of Kyverno. It was by Jim and Chip. So they talked about what are the things that are coming in 1.10, and even demoed some of the cool things. So here I'll be just telling you the high-level items, but feel free to take a look at the webinar. It's very informative. So one of the things is we are decomposing Kyverno webhook and controllers. So in the earlier architecture diagram, we saw that Kyverno has a webhook, it has multiple controllers, and so on. But some of our users have expressed interest in using Kyverno only as a webhook. They don't need all the background scanning. And some users want only background scanning. They don't need the other part. So for that reason, we are decomposing Kyverno, making it more modular, and you will be able to use only the features that you want, and you don't have to use the rest of them. So the decomposition activity is going on, and then we can do intra-cluster service API calls. So as long as your service API returns some form of JSON, it is very much possible to make an external cluster service API call and then write policies for them. And then we have Notary V2 initial support. Right now, Kyverno supports only cosign, but we also intend to support Notary V2 in the upcoming release. And then we have a bunch of other factors and enhancements. So this milestone has a list of all the issues and features that are piled up for 1.10. So you can take a look. Yeah, so that was about Kyverno. What is Kyverno, what's new in 1.9, and what's going to come in 1.10. Now I'll hand over to Dolis to talk about secure self-service clusters. Over to you, Dolis.
Thank you, Anusha. So let me share my screen. I think, Anusha, you have to stop sharing your screen. Perfect. So let's dive deeper into today's topic. That is, I hope you are able to see my screen, right?
No, try again.
No? Okay. It says host disabled screen sharing something.
It says to me that you should be, okay, it's working.
Yeah. Okay. So yeah, let's dive deeper into today's topic, which is secure your self-service cluster with IAC and Kyverno. We'll talk more about what kind of workflow does that look like, what is self-secure cluster. But before diving deep into that, we already discussed what is Kyverno. So let me take this opportunity and talk about what is IAC. Now, we all know what is IAC. It is basically managing and provisioning your infrastructure using code. So with the help of this approach, what you do is it helps you in a more structured way of managing infrastructure, where you can actually use just a code to deploy your infrastructure and helps you to avoid any kind of human error, or it also saves a lot of time. So think of it in this way, where your code is entirely in GitHub, it's auditable, it's repeatable, and this approach, you can use it in case you want to just spin up something in dev or QA, or in case you want to bring up some infrastructure down and just spin up something in any other region. It becomes more easy and convenient way of handling infrastructure, and it gives you more consistency where all your infrastructure as a code is in GitHub. So you're doing a lot of versioning on that. You can roll back if you're getting some errors. So all these functionality is something that IAC provides. Organizations today are using IAC a lot. So we have different tools available out there for IAC. We have Terraform, we have Crossplane. In this demo, I'm going to talk more about ACK, which is Amazon Controller for Kubernetes. So this is one approach of handling your infrastructure. You add it with Kyverno and you can secure this infrastructure. But let's talk about what is self-service cluster model. So basically, self-service cluster model is a Kubernetes way of enabling your developers or team to create and manage their own Kubernetes cluster without requiring any kind of interventions from your central platform team. So in this model, what happens is that the platform team actually provides a set of predefined policies and configurations, and these can be actually absorbed by your developers, and they can create their own self-service cluster. So typically the steps involves is that the platform team defines a set of policies. They define standard configurations that is used or that can be helped to govern that cluster. And then the cluster can be created, that can be managed and accessed. These policies might also include security settings, resource quota, access control, basically anything that you want to standardize, but still you can enable your developers to create your own clusters and enable them to manage their own clusters accordingly. So developers, what they can do is they have their own CLI, or you can create some portal where they can log in and they can request cluster and they can create their own cluster, provided that you have added some or exposed some field where they can add like desired size or their cluster name, entirely controlled by platform team, but still giving that functionality to create your own cluster to the developers. Once in the form of CLI or in the form of portal, once the request is triggered, in the backend, it hits the entire orchestrator and it provisions the cluster in the backend, and then it generates some kind of kubeconfig or some kind of RBAC policies using which the developer can access the cluster. So this is standard model steps. Now there can be different variation to this. There can be different, you can tweak it in different way, but this is the standard model of how can you use the self-service cluster in your organization. Now, the reason why we want to why we are moving or why we are more interested in using such kind of model is it actually helps you with a couple of points which I'm presenting over here. The first is that, of course, it helps the developers to create their own cluster, so they don't have to be dependent on any other team and all the overhead of, reaching out to platform team, they're doing a couple of things manually or provisioning it to developers. All this you have to cut. You can cut that out all. So what it does, it gives you a faster time to market. It increases the agility and flexibility. So now developers can actually experiment with new technologies, approaches without waiting for the central team to actually provide them the infrastructure. Not only that, it also improves the resource utilization because it's not just creating clusters. The developer can actually scale them down or delete it once they have finished their development. So they don't have to, again, rely on some team or operation teams always keeping an eye if the cluster is actually required or not. Developers can actually create a cluster, test their application, and scale the cluster down. So that will, of course, improve all of your resource utilizations. And there can be consistency of policies and configuration across all these clusters. So this is, you're providing this approach to the developers without compromising the configuration standards and compliances of your cluster that you want across your organization. So that's the perfect reason, or these are some of the points that we should consider why we are using SSM and why it is the best approach to get adopted in your organization. So in today's demo, what we are going to do is I'm going to start with some of the parameters that I'm using. I'll show you a workflow of how you can use self-service cluster, what will be the developer's workflow look like, what will the platform team workflow look like. And these are some of the components on the screen that I'll be using in today's demo. First is the Amazon EKS. So that's nothing but Amazon controller for Kubernetes. Basically, this is like a control. This is an AWS project, which is nothing but a controller, which can deploy and provision services in AWS for you. So this controller sits in your Kubernetes cluster, and what it does is it enable your Kubernetes cluster using which you can provision and create AWS services in the backend. So one component, and this is IAC, which we are using in today's demo. You can easily replace it with Crossplane. You can easily replace it with Terraform or any other IAC model that you're using internally in your organization. The second component that we are using is Kyverno, and Anusha has talked enough about Kyverno, why we do it, and why we need Kyverno and policies in our setup. So she was talking more about how we can validate policies, we can have pod security policies, how we can make our clusters secure. But in this demo specifically, I'll focus more on how Kyverno can actually help you to automate an entire workflow. So you can use Kyverno to validate some policies or validate your configurations and set up like governance and compliances for your cluster, but you can also use Kyverno to mutate and generate some resources. So Kyverno have different kind of policies. One is validate, mutate, and generate. We are going to use majoritarily generate policy, which is perfect example of Kyverno that can be used in your automation workflow as well. And then I'm using Argo CD. You can use any GitOps application in this setup. Today I'm using Argo CD that will deploy. Once the developer's cluster is created, it will deploy a couple of add-ons, like you might have certain standard applications, like maybe monitoring applications, maybe a secret manager application. So it will deploy those applications just standard on the developer's cluster once this is up. So yeah, going more into this, we'll talk about the architecture, of course, but I'll just show you what does this look like in real time. So I have this cluster, which is basically a 2-node cluster, and I have all the setup ready over here. We'll talk about what does the setup look like and what is the what are the policies and other kind of configurations. That is one-time configuration the platform team needs to do. But I'll talk more about, I have this ACK deployed over here. I have Kyverno. I have the Argo CD deployed over here as well. But let's talk about what does the developer workflow look like straightforwardly. So I have this CRD, which is create cluster Kubernetes custom resource, which the developer can use and request a cluster. Here I have just exposed the name and the desired size. So you can actually, you have the control of exposing if you want to expose the region, if you want to expose maybe the subnet role. I've hard-coded that into the Helm chart, but here you can expose this. Here I'm exposing just the desired size and name. So the developer can use this YAML. And this is the management cluster I have. So I've also created a namespace over here, which my developer team will have access to. So this is the team A, which I'll give the team A access to only this namespace. So what the developer can do is they can actually apply this resource YAML in the namespace they have access to. Once this is applied, the CRD will deploy, do a couple of bunch of automations it will trigger in using Kyverno's mutate and generate policy, and it will provision a cluster in the backend. And a developer can actually describe this CRD, and it can actually see if the cluster is created or failed. So here you'll see it's saying creating, and all the hard-coded configurations that I have put in, that is, let's take a look, this one, there's subnet, there is role, there is endpoint, all of this is hard-coded. Some of this which developer have added is name and desired count. So all of this you'll be able to see over here in details, and you'll see if it is created or it's in the process of creating. So once this is created, the developer will actually see this is active, and he will get a kubeconfig file as a form of secret in the same namespace which they have access to, and using that they can create or they can get access to their cluster. In the backend, let's see. So this is my AWS console, and if I refresh this, I see that this cluster is automatically created in the backend. And I'll see this is the app, this is the Argo CD I have, which is locally I'm using this. And I'll see that there is an application which is automatically registered in Argo CD, and there are a bunch of components which are responsible to deploy my cluster resources. I have cluster VPC CNI, I have my test cluster itself, I have node group, and all these bunch of things. So once this cluster is created, there'll be other set of automations that will get triggered. But this is what the workflow looks like. This is as simple as it can be, that a developer will just log in, use this request.yaml resource and add the name, desired size, and ta-da, it's done. The cluster is created. So now he'll get the kubeconfig file, access the cluster, deploy its application, do all the testing he wants, and then he can just delete the cluster whenever it is done. So now this is the front side of what it looks like. Now let's talk about the automation, or let's talk about the components, and let's talk about how Kyverno and policies we have used to do all of this automation. So I have a bunch of Kyverno policy over here that I can show you. So starting from step 1, I have actually deployed. Let's go in here. So I have deployed, this is the managed cluster I'm using, and this is the tenant cluster / developer cluster we are calling it. So in my managed cluster, I have all the one-time configurations I need. So this is the ACK, which is Amazon Controller for Kubernetes, which is nothing but using some YAMLs, you can actually trigger a EKS cluster in the backend. So this is creating a cluster for us. But this is Kyverno, where all our policies and all our automation policies are. And then there is Argo CD, which is deployed. So let's look at what does it looks like. So I have a couple of policies over here. Let's start about creating a cluster policy. So if you look at this policy, so if you look at this policy, you will see that this policy is actually getting applied on my create cluster CRD, which was nothing but a developer, which the YAML the developer was using, and the resource that developer was using to create a cluster. So it's getting applied, matching on this resource, and then it is checking some preconditions as well. And then it is taking the cluster name, it's taking desired size from the YAML that a developer has specified and using it like a variable. And then there are some hard-coded values that I have added over here. Now, this is what I was talking about when I was saying you have the entire control of changing the subnet IDs and other stuff. So what you can do is you can add it in the YAML in case you want the role that the developer should give it, or maybe the region or availability zone. Availability zone doesn't come here, but maybe region, subnet, other set of configurations. So some of them I have defined as a variable over here, other I have hard coded. You can duke it in your own way. Once all of this is over here, what it's going to do is it's going to generate an application for me in Argo CD namespace. So this is what Kyverno is doing, where it is taking all the configurations from a developer's request YAML, and some of them are hard coded in the policy itself. And it is generating this application for me in the Argo CD namespace with a cluster name, right? And this is why my application gets created over here the moment the application resource is created in the Kubernetes cluster for me. So this is what's triggering this. And if you will see in the ACK, I have a couple of the in the Argo CD application. If you will see, I have defined my repo URL, and I have defined this application Argo CD where it should fetch the blueprint of ACK. So I have over here entire blueprint of what does the ACK YAML looks like. I have an entire, I have the cluster YAML, I have other set of Helm charts that are there over here. So I'm adding this repository URL in my Argo CD's application. So that's where in your Argo CD, once this application is triggered, it will fetch the GitHub branch head, and it's going to pull all the blueprint, and it's going to start deploying the cluster using ACK in the backend, right? So perfect. So this is how the cluster is created. Now this is still creating, which will take some time. Now let's talk about other set of automations, because we have created the cluster is ready, but it's not always end over there. There are a couple other set of things that we want to make sure is deployed on the cluster once it is up and running. For example, my cluster should have all the policies, all the compliances. This cluster should have some standard monitoring tools, maybe, so that I can monitor the cluster. I can get the logs of the cluster. I can maintain all the compliances of my organization and the standards and best practices. So I have another policy over here. Let's just take, which is register the cluster. So once the tenant cluster or the developers cluster is created, I have this another policy, which is register the cluster. What it's going to do is, let's take a look. Okay, yeah. So this font was still good. I'll go with this one. Yeah, so this is a register cluster policy. What it's going to do is it's gonna again work on these resources. It's gonna match for these resources, and it's gonna check for the active status of the cluster, so that once the developer cluster is inactive, it can actually register the cluster in Argo CD. So in order to register the cluster in Argo CD, you require a secret that has the cluster details and credentials so that it can get registered in Argo CD. So that's what the policy is actually doing. It's actually fetching all the cluster name in the help of variables. It's taking the cluster ID, the tenant, the server name, all the details that you will require to create the secret and register this cluster in Argo CD. And it's taking all your authentication, like the roles and all that stuff. And then it is actually generating a secret for you. So it's generating the secret in the Argo CD itself, which in the backend registers this cluster in Argo CD, right? With the help of all these variables that we have taken in order to authenticate and create a secret and register this cluster in Argo CD. So let's take a look at whether our cluster is created or it's still creating, which is going to take some time. So yeah, this is one thing. So once this cluster will be in, and that should be in a couple of minutes, let's take a look what exactly is happening. Yeah, so it should be up because the networking is up. So overview should be up in like a minute or two. So yeah, once this cluster, which is your developers cluster, will be up, it will automatically get registered in Argo CD. And then I have deployed using this policy that we have, that we saw. And then I also have one more policy that I'm going to show you. Which is the kubeconfig file policy. Once the cluster is created, registered in Argo CD, I have this policy which is going to fetch all the cluster details, again, going to get applied on the CRDs, and then going to check for your cluster whether being active, and going to get all these variables for your cluster name. Some of the other things it's going to do is the endpoint, the certificate authority, other stuff which you require for in your kubeconfig file. And it's going to create an entire kubeconfig file for this cluster. And it's going to create a secret which will have this kubeconfig file in the namespace which the developer will have access to. So once the cluster is up, it is going to get registered in Argo CD, and then you'll have a kubeconfig file which will be generated as a secret in a team A namespace in this case, so that the developer can take that kubeconfig and start accessing the cluster and deploying the application. So yeah, these are three of the policies that I have. I also have some of the applications that I have created, which is nothing but app set. So once the cluster is up and running, I think that it came up. Let's take a look. Yeah, so now you'll see the cluster is active, which is great. If I go back in Argo CD and if I go in settings and if I see in cluster, my cluster, which was ACK test cluster, is registered automatically using the second policy, which was a register cluster. And then I have some app sets that I have deployed on this cluster. So I also want to make sure that all my standard application Kyverno is deployed on this cluster to start with. And there are some policies that are deployed so that the developer has that functionality. I want to enable the developer to deploy applications, but also want to make sure that all the bad pods and all the pod security policies and all the security checks are there in place for this cluster as well. So because of that, I've deployed Kyverno here. I've deployed set up policies. I'm deploying some more Nirmata controller or some other applications. It can be like your monitoring applications, other app sets which you require, right? And how I've done that is I have these application sets in Argo CD. So I've deployed it and it is telling me which is healthy, which is deployed, which is not, right? So yeah, these are some of the things that are there. Now I can log into my developer. I know I'm running, we are running out of time, but what I can do is quickly, I can just log into this ACK cluster, and I can show you what is getting deployed over here. So this is the developer's cluster, and this is how it's going to look like, where you'll see that Kyverno is automatically deployed. It's like 2 minutes before it deployed all sort of things. And then the policies are also deployed since they are not ready, but they are just deployed and they'll come up, they'll be ready. And then you'll see that the developer will not be able to deploy any kind of bad pods on this cluster. In the same way, you can do it using Terraform as well. So we also have like a Terraform template using which you can use the same thing. So there is this main.tf Terraform file. In this, you can use Kyverno as a Helm chart, and you can deploy, like you can add this in your existing pipeline. If you're creating a Terraform cluster and that is getting triggered by your developer, you can add in an exact pipeline. You can add like a Helm chart for Kyverno. You can add, we have best practices and all the policy sets Helm chart. So you can add all those best practices policy chart in the same main.tf, which will help you to trigger everything in one go. And once, so yes, this is what we were talking about. If I go back very quickly and show you what does the model look like, this is what it looks like. I have all the 3 components, and then I have this 10 cluster created, and I've made sure that Kyverno and policies and all my add-ons are deployed on this cluster. Cool. So yeah, I'll take a stop there, and Anusha can really wrap up with other set of maybe like some other components, and then we can be good to take questions.
Thanks, Dolis.
I'm unable to stop video.
Really interesting.
Yeah, but I can share screen. I can, yeah.
Yeah.
This. Yeah, so thank you, Dolis. I'll quickly take another minute to wrap it up. So yeah, so this is the Nirmata policy manager that I wanted to talk about. So this is a SaaS-based control plane wherein you can have a quick summary of all your clusters. So like you see, you can onboard clusters. In this screenshot, I have 7 clusters onboarded. There are 96 policies across them. You can see how many passed, failed, or how many warnings are present. The Nirmata policy manager also provides compliance in terms of best practices. There are industry standards like CIS, Kubernetes benchmarks, and there are also Nirmata standards such as multi-tenancy. We have RBAC best practices and so on. And you can view violations by different categories. You can view violations by different cloud providers. So this platform is cloud provider agnostic. Unfortunately, here we have only AWS, but it works with Azure, GCP, even your local clusters. And yeah, some quick stats on which clusters have the max violations, which namespaces have the max violations. So this is a quick dashboard view, but then there is a lot of other features baked into it. And if you want to try it out, you can head over to try.nirmata.io, and we offer a 15-day free trial. So please give it a try and let us know the feedback. That's all from my side. Thank you.
Cool. So folks, if you have any questions, we still have like 5-7 minutes. We can take them. We can talk about, was that helpful? What do you think about it?
Yeah, I'd say, if you don't mind, that I found it really, really interesting. And what I really loved in regards to the presentation is the fact that you try to explain that in the end, creating a platform is required and must be self-service. And every time I try to talk with people in regards of multi-tenancy, multi-tenancy is a broader term, and you can do a lot of stuff, because in the end you can talk about multi-tenancy in the cluster management, in the application delivery. And I say that the golden rule to define something that is multi-tenancy is the fact that it must be self-service. And what I really love in regards of Kyverno is the fact that it allows to create a self-service platform in the end. And I'm really happy to have you here as Nirmata, as Kyverno developers and maintainers and so on and so forth, because in the end you are able to share with the people this knowledge, and I'm really happy for that. So it wasn't a question, but just sharing that. I really love the presentation.
Thank you.
So all the people that are attending the webinar, if you want, you can unmute yourself and ask the question, or rather write in the chat. Don't be shy.
Hello, Dolis. Yeah, this is Rohan.
Hey, Rohan.
Yeah, so I just wanted to know, like, what is the cost of like Kyverno? Like, if you want to like integrate with our cluster, like with our organization, so what will be the cost? Like, what will be like how we can start?
Sure. So Kyverno is actually open source, so we don't have any cost associated with Kyverno. So you can actually go to kyverno.io and you'll get all the details over here. So you can refer the documentation, installation, introduction steps. And as Anusha was saying, that we have policies 265. So you'll find policies for every use case over here. So yeah, you can explore it. Let us know how does that work. And we also have Slack channel for Kyverno. So if you need any kind of help, just ping us over there and our team will be happy to help you.
Okay, so I thought there is an enterprise support. I thought.
Yeah, there is, of course, there is an enterprise support which Nirmata provides, which Anusha was talking about, NPM, Nirmata's policy manager. So yeah, of course, there is enterprise support. You can reach out to us and we can help you with more details for the enterprise support. If you want to check Kyverno, I have sent you a link for the Kyverno doc. So there you'll get all the details about the Kyverno and policies. And for the enterprise details, you can reach out to us.
Yeah,
Okay,
and I'm also
fine.
dropping in
So
the
policy
link
manager
for a free trial.
is part of open source, correct?
So
Sorry, Anish. Hello.
Yeah.
Yes, you're saying something.
yeah, I
Yes, you
think I
can
have,
continue.
sorry, maybe bad internet. Yeah, I just dropped in the link for the free trial from Nirmata. So like Dolis showed, you can start with the open source version, like give it a spin, see how it works in your environment, and you can also then maybe try the enterprise version. Yeah.
Okay, so we can directly integrate ACK, Argo CD, and Kubernetes cluster directly with the open source, correct? There is no need to
Yes.
have enterprise support.
That's right.
Okay, fine. Sure.
But the
Thank you.
policy manager screenshot that I showed at the end, so that is the enterprise version.
Okay, nice. Okay, that's it from my side. Thanks.
Thank you.
Any further question? Because it seems not, and I'd say that since I'm based in Italy, so Central European time, it's time to get a drink, at least for me.
And it's Friday already.
And it's Friday. Yeah.
I just want to ask, like, whether like you have used Terraform also, right, with ACK. So what do you think, like, which is better, like ACK with Terraform? What is the advantage of using ACK?
Yeah, so ACK is basically just AWS project. So if your infrastructure and everything is in AWS and you have like you want to enable, like you want to use Kubernetes API to deploy your services in AWS, that's what your use case looks like. Of course, ACK is the best choice. If you have infrastructure all over the place, if you have Azure, you have pipelines, you don't want Kubernetes cluster to actually trigger those workflow, but you have a different workflow for your IAC. Terraform is like globally used for all the other infrastructure. So it actually depends upon use case. It's not always like best answer for, you know, what we should use or what is good. It is more towards what is your use case, what are you looking to provision, and then what fits your requirement.
Okay. Fine.
Okay, I think that we can consider it done. So I would like to thank Dolis, and I'm sorry, I forgot the name, Anusha.
Anusha.
Yeah, I'm really sorry for that. But it was a pleasure. So just a brief reminder. So we are from the Kubernetes Multi-tenancy. So if you at the time, please sign up on our meetup.com group, so we can discuss further about multi-tenancy. Reach out to me and Marcello in regards of topics you would like to get, and also remember to vote the session that we had. So if you join there from Meetup, you should get also an email saying if you enjoyed the webinar. And for my 2 cents, it was great, as I said before. So keep in mind that we are going to upload also this session on the ClastixLabs YouTube channel. And if you have any question, please use the Meetup page, and we are looking forward to answering all of your questions. So Dolis and Anusha, thank you so much, and enjoy your weekend.
It was great.
Cheers.
It was a pleasure meeting you.
Bye-bye.
Have a great weekend, folks. Bye-bye.
Bye-bye.